Welcome to 4.6 Related Rates, page 4. We're looking at this example number 6. Sand is being dropped at the rate of 10 meters cubed per minute onto a conical pile. If the height is always twice the base radius, at what rate is the height increasing when the pile is 8 meters high? Alright, so we have sand being dropped onto a conical pile. A conical pile is a cone-shaped pile, so let's draw that. And what's really happening is sand is probably coming down some sort of chute here. And that sand is falling onto that pile, and as that sand comes down, the pile of sand gets taller and the base radius of that cone gets wider. We want to know how fast is the height changing when the pile is 8 meters high. Alright, so looking back at your bullet list, read the problem. Got it. Draw a well-labeled diagram. Almost. The two dimensions in here. Radius and height. Radius and height. Okay. List any numerical facts about what we know or what we want to find. What do we know and what is it that we want to find? We know that the sand is falling at a rate of 10 meters cubed per minute, so that's a volume measurement. dV dt is 10 meters cubed per minute. And we want to find at what rate is the height increasing. So find dH dt when the height is 8 meters. And we have another piece of information in here. And that piece of information is that the height is always twice the base radius. Height is twice the base radius. Now I do want to caution you that that piece of information is for this cone only. Some students mistakenly think that that information is true for all cones. It is not. It's this cone only, and only because I told you that the height is twice the base radius. Alright, now looking at our variables here and to write an equation, we have volume, height, and radius of this cone. So you remember your geometry. Volume of a cone is 1/3 pi r squared h. But we have a problem in here because we have too many variables going on. I only have two rates, dH dt that I need to find and a dV dt that was given. If we do this derivative as written, we'll have two variables right here with the r squared and the h, and we'd have to do a product rule, which would introduce a dr dt. We don't have that. If I just said that too fast for you, go back and listen to it again. So what we're going to have to do is get rid of this r here, and we can get rid of that r by dividing this little bit out by 2 and get that r is h over 2, so that this volume equation simplifies down to be so I took out that r. I should have replaced it with h over 2, not r over 2. I think I was trying to think about the pens too much rather than the substituting. Alright, now let's simplify. Even though it's specifically not written in the directions, we always simplify anytime we can along the road here. And this is h squared over 4 times an h, which will give us 1/12 pi h cubed. Now do a derivative. I'm just putting a note here to simplify before differentiating. And the reason we do that, if we didn't do that simplifying first, we'd have to do a product rule right here between this h over 2 squared and that h. It's much easier to get rid of that product rule by multiplying everything out. Now do a derivative. dv dt, this 1/12 pi, constant multiple comes down. Derivative of a h cubed is 3h squared, dh dt. And then simplifying, we have 1/4 pi h squared, dh dt, is dv dt. All right, now substitute in the given rate. And the rate we were given in this one is that dv dt is 10. So we can put that in. And now solve for the desired rate. And this time we do have to solve. On page 3, previous problem, we did not have to solve for that desired rate because it was already done. This one we do. Solving for dh dt, multiply by 4. That's going to give us 40, and we'll divide out that pi h squared equals dh dt. So there we've solved for that desired rate. And the next step then is to evaluate at the point that we're interested in. So we want to find dh dt when h is 8 meters. And subbing in here, we'll have 40 over pi times 8 squared, 40 over a 64 pi, which simplifies to be 5 over 8 pi. I do want you to check this on your calculator and double check, seriously do this. Make sure that when you type that into your calculator, you can get approximately 0.198, not 1.96, I believe was the incorrect answer. You have to make sure that you divide by this 8 pi. Don't just do 5 divided by 8 times pi. Make sure you're dividing by this entire 8 pi, so put it in parentheses if you need to, or use the fraction bars, something. Make sure you can come up with 0.198 on your calculator. Final answer then is to write this out, and this is the rate at which the cone's height is increasing. So we'll say the height of the cone is increasing at a rate, mess, and I don't have any white out, at a rate of, now you can write it as the exact answer, 5 over 8 pi, and these are meters per minute, or you could write it as the decimal approximation, 1.98 meters per minute, when the height of the sand pile is 8 meters. Great. Thank you very much. Please tune in for page 5 tomorrow.